This video is for Math 112 for sample test number 2. So I'm going to be working off the sample test that I posted to the course website. You've got 3 identities on the first page that you need to prove. You've also got a list of identities there to use. And then on page 2, you've got 3 equations to solve. So let's go ahead and get started on these. Problem 1, we need to prove the identity that says is cotangent theta minus tangent theta equal to 2 times the cosine of 2 theta over the sine of 2 theta. Okay. Let's see. So I'll work on this side first. I'm going to leave that cosine 2 theta alone for a minute, and then I'll rewrite sine of 2 theta using its identity 2 sine theta cosine theta, and that allows me to cancel these 2's out. And then let's see here. I'll just leave it like this, cosine 2 theta on top and sine theta cosine theta on the bottom. Okay. Over here, everything over here is in terms of sines and cosines. So let's rewrite these as sines and cosines. This one is cosine theta over sine theta. This one, sine theta over cosine theta. So we want to make a common denominator, and not coincidentally, this is going to be the common denominator, sine theta times cosine theta. So to create that over on this side, I need to multiply this one by cosine over cosine, and this one gets multiplied by sine theta over sine theta. And so we end up with cosine squared theta minus sine squared theta over cosine theta sine theta. And we can take the extra step and call this numerator cosine 2 theta. And then we're done. And there we go. Okay. All right. Let's see here. Problem 2. We want to show that secant squared x plus cosecant squared x is equivalent to secant squared x times cosecant squared x, which is actually kind of interesting. That if you add those 2 quantities together, it will be the same as if you multiply them. Okay. All right. Well, let's see here. Over here, there's not a whole lot we can do other than rewriting these using the reciprocal identities. 1 over cosine squared for the secant, and 1 over sine squared x for the cosecant. And so this will just be 1 over cosine squared x, sine squared x. Okay. Over here, it's going to be 1 over cosine squared x plus 1 over sine squared x. And again, we have to make a common denominator. And just like in problem 1, this is going to be our common denominator. So to create that over on the left-hand side, this one gets multiplied by sine squared over sine squared, and this one gets multiplied by cosine squared over cosine squared. Excuse me. And so we end up with sine squared x plus cosine squared x over sine squared x times cosine squared x. And of course, what's in the numerator is equivalent to 1. And there we go. There it is. They're equivalent to each other. Okay. Let's take a look at problem 3. Problem 3, want to show that this is equivalent to 2 secant x tangent x. Alright, let's see here. I think it'll be helpful to rewrite everything in this problem in terms of sines and cosines. So that's 1 over the cosine, and this one, it's sine over the cosine. So we end up with 2 sine x on top and cosine squared x on the bottom. Okay. Over on this side, we want to make a common denominator so we can add these two fractions together. So this one needs to get multiplied by cosecant x minus 1 over cosecant x minus 1. And this one gets multiplied by cosecant x plus 1 over cosecant x plus 1. So, what do we get as a result? In the numerator, we're going to have cosecant x minus 1 plus cosecant x plus 1. In the denominator, we're going to have cosecant minus 1 times cosecant x plus 1. So on the top, the plus 1 and the minus 1 make 0, and we end up with 2 cosecant x. In the denominator, if you multiply these together, we get cosecant squared x minus 1, which is one of the Pythagorean identities. So we can replace that with cotangent squared x. Alright, so now we want to show that this is equivalent to 2 sine x over cosine squared x. And if we just take this and rewrite it in terms of, let's see here, sines and cosines, cotangent squared is going to be cosine squared over sine squared. So 2 over sine x times sine squared over cosine squared. That'll cancel one of these and give us 2 sine x over cosine squared x, which is equivalent to what we got on the right-hand side. Okay, so there are the identities. Let's take a look at the equations from page 2. Okay, so problem 4, we've got tangent squared x plus 4 equals 2 secant squared x plus tangent x. So the key here is really to identify the linear term. The tangent is the linear term. So we want all of the squared pieces to be in terms of tangent. This one is fine. This one we should change. And just like we saw in class, if you've got a coefficient, we've got this coefficient of 2 here, and so the tangent squared x plus 1 is going to go in parentheses, and that 2 is going to get distributed. So we'll have 2 tangent squared x plus 2 plus tangent x on this side, and tangent squared x plus 4 on the left-hand side. So I'm going to move everything over to this side and write this as a quadratic equation in standard form. Okay, so this will be 0. Over here we'll get 1 tangent squared x plus 1 tangent x and then minus 2 equal to 0. All right. So we run this through the quadratic equation. What do we get? Yeah, this is also factorable, which means that we're going to get whole numbers as our answer. So tangent could be 1 or it could be negative 2. So let's take the inverse tangent of 1, and that gives us 45 degrees. And I'll come back and find the other angle in a minute. for tangent x equal to -2. If we do inverse tangent of -2, we get an answer of -63.4 degrees. Okay, so for the tangent to be positive, that's going to be a third quadrant angle with a reference angle of 45 degrees. Add that to 180, gives us 225. Over here, this is saying the tangent is negative in the fourth quadrant with a reference angle of 63.4. And so that should be 296.6. And then there's also an angle in the third quadrant. Let's see, 180 plus 63.4 should be 243.4, I believe. Yeah. Okay, so there's those two answers. There's those two answers. They're all between 0 and 360. That's what the problem asked for. And they're also rounded to the nearest tenth of a degree. Okay, these came out as exact values, and that's fine. All right, let's take a look at problem 5. So 5 cosine 2x plus sine x equals 4. And again, identify the linear term there. It's a sine function. So that means we want to use the identity for cosine 2x that involves the sine function and not the cosine function. And again, we're going to need parentheses in here so that we can distribute this 5 to both of these terms. 5 minus 10 sine squared x plus sine x equals 4. I'll move everything over to the right-hand side. So we'll get positive 10 sine squared x minus the sine of x. And if we subtract the 5 over there, we should get minus 1. Okay, so let's run this through the quadratic formula. Let's see here. There we go. And so we get sine of x could be 0.370156. Negative 0.270156. So I've said this before, I've mentioned this a couple times, the importance of accuracy in your problems. Now the problem asks you to round your answers to the nearest tenth of a degree. These are not your answers, they're not in degrees, don't round them to the tenths place, okay? When we find the inverse sign of one of these numbers, then that result should be rounded to the nearest tenth of a degree. Okay? I highly recommend using the variables that these values are stored in on your calculator. But if you're not going to do that, please take at least 4 decimal places when you're doing these problems. It can make a difference of at least 4 or 5 degrees in your answer. Okay, so we want to do the inverse sine of 0.370156. That gives me 21.7 degrees. So 21.7 degrees. And then I'll do the inverse sine of this one, negative 0.270156. And that's telling me negative 15.7 degrees. Okay, so let's take our answers here. For this one, we've got an angle of 21.7 degrees. The sine is also positive in the second quadrant. And so if we have a reference angle of 21.7 there, the other angle will be 158.3. So 21.7, 158.3. And then this one, we've got an angle of negative 15.7. So that corresponds to a reference angle of 15.7 in the fourth quadrant. And that would be a fourth quadrant angle of 344.3. And then let's see, the sign is also negative over here. Put a reference angle of 15.7 in there. And that'll be 195.7. And it's important that you communicate your answers clearly, okay? If your answer is scribbled in some corner of the page and I don't see it, then that's not my problem, okay? You need to communicate your answers clearly to the person who's grading your paper, okay? So that is problem 5. We've got one more equation to look at. So let's go ahead and take a look at problem 6. Problem 6 is pretty straightforward. We just have a single trigonometric function, the cosecant. We've got 2 cosecant squared plus the cosecant of x equals 6. And all we need to do to put this in standard form is to subtract 6 on both sides. And there we go. Okay, so now we've got a quadratic equation in standard form. And we'll use the quadratic formula to solve it. Let's see here. 2, 1, negative 6. So I'm getting cosecant x could be 1.5 or it could be negative 2. All right. If you want to think of this in terms of fractions, that's 3 over 2, because what's going to happen is that we need to take reciprocals of these. That says that the sign is going to be 2 over 3. You can call it just 1 over 1.5 if you want, or negative 1 over 2. Okay? So that's what we're working from. We want to do the inverse sign for these values. So the inverse sign of 2/3 is going to give us what? 41.8 degrees. And then also in the second quadrant with a reference angle of 41.8, that's going to give us 138.2. Okay, let's see. All right, then we want to do the inverse sine of negative 1/2, and that should give us negative 30 degrees. Yeah. So in the fourth quadrant, a reference angle of 30 degrees would give us a fourth quadrant angle of 330. And in the third quadrant, where the sign is also negative, that'll give us an angle of 210. So there's our 4 solutions for problem 6, clearly indicated. And that's it. So that's it for the test. Like I said in class, you're just going to have 6 questions, 3 identities, 3 equations to solve. You're going to have a list of identities on your formula page. We'll talk about this in class on Monday, and if you have any questions, we can bring it up then.